Have you ever been stuck with a compile error that just doesn't make sense? It's frustrating, right? If you're dealing with a Clang compile error related to static assertions and Boost.Hana, you're in the right place. Today, we're going to unravel this issue together. I totally get how annoying it is when your code compiles one way, but fails spectacularly when you make a small change. You're not alone in this. Many developers face similar challenges, especially when working with complex libraries like Boost.Hana. Here's the specific situation we're looking at. One user recently asked, "What causes the second version of my code to fail with a compile error?" They provided two code snippets, one that compiles successfully and another that throws an error about a reference to a local variable. Sound familiar? Let's dig into this together. So, what could be causing this compile error? The issue arises from how static assertions work in C++. When you try to use a variable from a lambda inside a static assertion, it can lead to unexpected behavior. Let's break it down step by step. And don't go anywhere. I've got a crucial insight at the end that will help you avoid similar pitfalls in the future. To understand why the second version fails, we need to look at how static assertions work in C++. The user should note that static assertions are evaluated at compile time. In the second version, the user is trying to use the variable I directly inside the static assertion. However, I is a local variable defined in the lambda expression. The error message indicates that there is a reference to a local variable declared in an enclosing lambda expression. This means that the compiler cannot evaluate I at the point of the static assertion. In contrast, when the user introduces a new variable, like A, to hold the value of I before the static assertion, the code compiles successfully. This is because A is a constexpr variable that can be evaluated at compile time. In summary, the user should avoid using local variables directly in static assertions. Instead, they can create a constexpr variable to hold the value, ensuring that it can be evaluated at compile time. Fun fact: did you know that C++ was originally designed to add object-oriented features to the C programming language? It's come a long way since then, but sometimes it still throws us curveballs. Now let's look at the answers provided by other users. An alternative solution provided by a user points out that the issue is a bug in the Clang compiler. They have acknowledged this bug, and you can find more details through the provided link. Here's the insight I promised. Always be cautious when using variables from lambdas and static assertions. This small detail can save you hours of debugging time. And there you have it. You've learned how to tackle compile errors related to static assertions in Clang. Remember, understanding the nuances of C++ can make all the difference. If you found this helpful, hit the subscribe button for more tips, and don't miss our next video where we dive deeper into Boost.Hana.